Hi, my name is Charlie, and this is an art lesson. And today we're going to talk about color and light, and we'll make our own color wheel to help us organize how we think about color. I'd like to start with an illustrated demonstration of light, because color comes from light. And scientists look at light, and sometimes they think that it's a particle, a thing, a little packet of energy that moves very quickly through space. And sometimes it behaves more like a wave, going up and down and up and down. Sometimes the wave can be very wide, or the wave could be very narrow. The wave can be very tall, or the wave can be very short. But all these different waves, we can detect them in different ways. And it just so happens that some of these we detect by color. Where do these waves and particles come from? Well, any light source. The biggest one around here is the sun. It emits huge amounts of light in every direction, all of the time. Another source of light is, of course, a light bulb that emits light in lots of directions as long as it's plugged into an energy source, like a battery or a wall socket. And it needs to be turned on also. Another source of light is a candle or fire. And of course, it's only if it's lit. And light comes off in all these different directions. And these light sources each release all kinds of different waves: tall, short, long, narrow, and they go in every direction. This is an apple on a mat. And if the sun sends off a little packet of energy and it travels in a wave all the way across space and it hits this apple, some types of waves are absorbed by the apple and other types bounce off. And that's where we get color. But it has to bounce off into our eye, because we have sensors in our eye that tell us the exact size of these waves of these particles. In the back of our eye, we have tiny specialized cells that react when light hits them. And these cells are plugged into a nerve. And that nerve brings information to the brain. These different waves that we can see are the difference between the size of a virus and the size of a bacteria. They're very, very tiny. But our brain has the capability to detect the size of these waves. And we do that by sensing color. Now, of course, everybody's eyes and everybody's cells and everybody's brains are different. So some people might detect that color as green, and other people might think it's a gray or a dark brown. Or if it's a different kind of light, it might appear a different color. It depends on the light and the object and the eye. Now, this diagram is fairly simple, just following one kind of light from the sun off of the leaf into the eye. But really, light is bouncing all over the place. Sometimes light can bounce off an object and then off another object and then into your eye. And you might receive that and understand that you're seeing a reflection of an object, like this apple is reflected on the mat. So light is very complicated because it's going all over the place. But that's where color comes from. The color spectrum that the human eye can see starts at red, and the red wavelength is about 750 nanometers. And now that's 750 billionths of a meter. And we can see all the colors all the way up to violet, which is about 400 nanometers, 400 billionths of a meter. So when I color with this red colored pencil at the top of my design, it has some of the longest wavelengths, the biggest waves. And they get smaller and smaller as they go around this circle. And you're probably familiar with this type of work. Red, yellow, and blue make up the primary colors, and we cannot mix them. We just have to get them. But if we mix red and yellow, we get orange. And if we mix yellow and blue, we can get green. And if we mix blue and red, we'll get violet. And those are the secondary colors, which just means the second colors. And here we've made a circle organizing the colors. When we organize the colors in this way, it's very easy to see which colors are opposite each other, and we call them complementary colors. Orange and blue are complementary colors. And what that means is if you put them next to each other, they will make each other look better. They will complement each other. This blue will look more blue if it's surrounded by orange, and the orange looks to be brighter orange because it's next to blue. When we organize colors in this way, we can also see which colors are next to each other or adjacent. Colors that are next to each other blend in with each other and have a tendency to hide each other. Oh, my pencil is broken. This happens a lot with colored pencils, and for colored pencils especially, you will need to use a nice sharp pencil sharpener. And if the small hole for regular pencils is not working for you, sometimes the larger hole works for colored pencils a little better. It sharpens at a different angle so that the colored lead won't break as easily. There we go. These adjacent colors have a tendency to go really well with each other, especially when they're blended together. When adjacent colors like green and blue or green and yellow are layered over each other, they make a nice range of intermediate colors like yellow-green and blue-green. And that's a nice quality of adjacent colors. Complementary colors like orange and blue, when you layer them on top of each other, well, see what happens. Because the colors are opposite, they kind of cancel each other out, and we're left with a brownish, grayish, blackish color that looks a little muddy. Purple, or violet, and yellow are also complementary colors. Let's see what happens when I put purple over yellow. I hope that you have colored pencils to try this at home. This is just a color experiment page where I'm trying all kinds of different color combinations and seeing what mixed colors can make. Red and orange are adjacent to each other. They're right next to each other, so they should blend very well together. Can you think of anything that is red and orange blended together in a beautiful way? Maybe autumn leaves or a crackling campfire. Well, that's a color wheel and some color experiments. Remember, we talked about light and how color comes from the light source, the object, and the eye, and those three work together to perceive color. I also made a color wheel and did some color experiments. I hope you have some time to experiment with colors and see how many different varieties you can come up with at home. And as always, it was a pleasure and a privilege, and I enjoyed it to the utmost.